Hi there, and welcome to Science Sleep, where quiet curiosity meets peaceful rest. Tonight, we invite you to float with us on a strange and fundamental question. We rest in a world defined by an invisible, constant force. A force that holds the oceans in their beds, the air to the ground, and you gently in your place as you drift to sleep. It is the universe's most faithful anchor. But in this safe, quiet journey of thought, we are going to explore: when gravity fails, what if gravity flickered for 1 second? We won't explore the noise or the chaos. Instead, we will drift through the silent physics of that single, impossible moment. What would it feel like? To the air, to the sea, to the planet. As the universe's anchor was briefly, silently, let go. So breathe slowly. Let your thoughts settle, and allow Science Sleep to guide you into this quiet, drifting thought experiment. Imagine the universe lying in its eternal stillness, a cosmic ocean held together by a single, invisible force: gravity, the quiet architect of everything you know. It is gravity that shapes stars, gravity that pulls planets into orbits, gravity that keeps oceans on the earth, breath in your lungs, and time flowing in a familiar direction. And now imagine this force, the most reliable force you've ever lived under, flickering for 1 second. A tiny moment by human standards, but long enough to rewrite the shape of the world. What if the universe blinked? What if gravity, for the briefest heartbeat, simply let go? To explore this, you and I will drift into a quiet thought experiment. A slow, dark ambient journey through physics, reality, and the impossible edges of imagination. And we will walk through it as gently as possible, because what you're about to feel is both peaceful and terrifying, calming and catastrophic, scientific and dreamlike. Take a breath, settle your mind, and picture the world at the very instant gravity turns off. The first millisecond, gravity disappears, not weakens, not changes direction, not becomes unstable, just vanishes. For 1 millisecond, you don't feel anything different. Your nerves are slow, your senses too human. Your body has no time to register the absence of weight. But the world does. In that infinitesimal slice of time, everything, not anchored by chemical bonds, begins to drift. Air molecules loosen. Dust begins to float. Water in a cup starts rising, forming trembling spheres. Loose hair lifts away from your shoulders. The fabric of your clothes softens into a slow upward drift. The Earth, meanwhile, continues rotating exactly as before. Because rotation doesn't need gravity. Momentum is enough. The planet spins like a stone thrown long ago, free, in the darkness. But everything on Earth has begun unsticking. Not violently, softly, like the start of a dream, like the first note of an orchestra warming up. And then the next millisecond arrives. The first tenth of a second. Now the world notices. Buildings groan as their internal stresses change. The human body lifts a fraction of a millimeter from the ground. Water ripples upward. Paper drifts off tables. Birds lose the sky, not because they fall, but because there is no falling left to do. In this tenth of a second, oceans do something beautiful and terrifying. Their surfaces begin to lift, no longer held flat by Earth's pull. They bulge upward like living creatures, gentle at first, soft, almost peaceful. The horizon wavers. Clouds begin to expand, no longer pressed into layers by atmospheric weight. The ground loosens its grip on everything. This is not chaos yet. This is the quiet before chaos. A stillness so strange, it almost feels holy. 1 second of weightless earth. The full second arrives. Gravity is completely gone, and you are floating. Your body rises from the floor in a slow, dreamy ascent, like sinking upward into warm water. Your heart beats a little differently, because it is no longer pushing blood against the pull of down. Every organ shifts slightly inside you. A gentle rearrangement, painless but uncanny. Around you, the world lifts into the air. Cars, soil, trees shedding leaves in a silent upward rain. Water escaping its own containers. Rivers uncoiling from the earth, like snakes made of liquid glass. The deep ocean begins to erupt upward, not violently, but inexorably, a column of water rising into the sky, freed from every law that once held it down. Human cities become clouds of drifting objects. Chairs, books, microbes. Entire rooms unthreading themselves into the air. People float, arms outstretched, confused, weightless. Some are peaceful. Some are terrified. Some instinctively swim through air, even though air offers nothing to push against. And yet, this is only half of the story. Because gravity does more than pull things down. Gravity bends space. Gravity shapes time. Gravity anchors the Earth to the sun, and the sun to the Milky Way. Without gravity, even for 1 second, space-time itself begins to unweave. The cosmic consequences begin. The Earth continues orbiting the sun for that 1 second, because momentum keeps it moving. But the orbit is no longer an orbit, it is a straight line. Earth flies forward with the tiniest deviation from its normal path. Only a few meters, barely noticeable to humans. But the solar system notices. Every orbit shifts. Every gravitational relationship loosens. Planets slide a millimeter sideways. Moons drift slightly outward. The delicate balance of celestial mechanics bends, then snaps back. Because after 1 second, gravity returns, and the universe must correct itself. When gravity comes back, the return is instant, absolute, merciless. Everything that was rising stops rising. Everything that was drifting freezes in air. And then everything falls. Human bodies slam downward. Cars crash back to the earth. Oceans collapse into themselves with the force of 1,000 hurricanes. Clouds crash downward like invisible avalanches, compressing air hard enough to form shock waves. The entire atmosphere slams back into the planet. The earth rings, literally rings like a struck bell, sending seismic vibrations through its crust. Not world-ending, but unforgettable. 1 second without gravity was enough to store a planet's worth of potential energy in midair. And when gravity returns, that energy is released in a single, global instant. The human experience. For the people living through it, the experience is surreal. Weightlessness is strange, but sudden re-weighting is violence. Bones compress. Objects smash into the ground. Some cities go dark as power lines snap. Some towers survive, their cores engineered strong enough to handle forces far greater than a momentary loss of weight. The human memory of those 1 second stretches into eternity. People will remember floating. People will remember falling. People will remember the moment the world felt like a dream, then crashed awake. And scientists will begin the greatest investigation in human history. Because gravity does not flicker, should not flicker, has never flickered. Unless something unimaginable happened. What could make gravity fail? Physics provides only a few theoretical possibilities. All of them exotic. All of them frightening. All of them beautiful. 1. A quantum gravity glitch. Gravity at the smallest scales is poorly understood. If space-time is quantized, built from tiny space-time atoms, then a temporary failure could behave like a pixel flickering on a cosmic screen. 2. A gravitational wave of impossible magnitude. Something massive, incomprehensibly massive, could distort the fabric of space-time so violently that local gravity shuts off momentarily. 3. A passing defect in space-time. A cosmic string, a domain wall, a relic from the early universe drifting through the galaxy. If Earth passed through its boundary, gravity might blink. 4. A deliberate act of advanced physics, a manipulation by a civilization thousands or millions of years ahead of us. Experimentation with space-time metrics. Artificial gravity control. A test? Or a message? 5. A failure of the Higgs field. Mass itself depends on the Higgs field. If it rippled, even temporarily, gravity's behavior would shift. Matter would feel lighter or cease responding to space-time curvature. On the mine, to hind, on the winds, since time. Each explanation leads into even more impossible questions. If gravity flickered once, could it flicker again? The aftershock in human psychology. Even if the world survives the physical consequences, society will not be the same. People will fear the sky. People will fear the ground. People will fear the moment gravity may blink again. Governments will invest in gravity shelters. Air travel may be grounded for months. Scientists will argue endlessly about what really happened. Theories will multiply like galaxies. New religions will emerge around the moment of ascension. Artists will create entire movements inspired by that second of weightlessness. And philosophers will question whether the universe is stable at all. But beneath the fear lies something else. A strange, profound awe. Because gravity, for 1 second, revealed itself not as an invisible constant, but as a fragile thread holding reality together. And now the world knows how easily that thread can snap. When the universe blinked back, gravity has returned. But it has not returned quietly. It arrives like a command shouted into the fabric of existence. Everything that floated hangs suspended for a fraction of a breath. Everything that drifted upward, even by a millimeter, freezes. Time itself seems to pause. And then, the world falls. The entire Earth collapses back into its normal weight, with a violence it never evolved to withstand. Green shields of water crash downward. Billions of tons of atmosphere slam into the planet, compressed like a chest, suddenly forced to exhale. The crust shakes. The mantle trembles. The sky roars with pressure returning all at once. For 1 second, gravity failed. For many seconds afterward, gravity overcorrects, and the planet must relearn the pressure of its own existence. Aftershock of a falling world. You feel it in your bones first. A heaviness. A sudden overgravity effect lasting a fraction of a heartbeat. Your spine compresses by micrometers. Muscles tense instinctively. Your inner ear screams for balance, no longer sure which way is up. For a moment, the world feels twice as heavy. This is not because gravity actually doubled. It is because everything that floated must now fall all at once. The Earth is struck by its own belongings. Chairs, trees, loose soil, debris, oceans, people. The atmosphere itself punches downward, creating shockwaves, like invisible tsunamis racing through the air. Yet, the planet survives. Humans survive. Life survives. Because gravity failed for 1 second, but only one. Had the flicker lasted longer, everything would be different. What if gravity flickered for 10 seconds? 10 seconds without gravity is not a scientific inconvenience. It is a mass extinction. Not just for Earth, for the entire solar system. Here is why. 1. Earth would leave its orbit. Without gravity, Earth no longer curves around the sun. It moves in a straight line away. 10 seconds is enough for Earth to drift tens of kilometers off its orbital path. The sun's gravity cannot correct this perfectly once it returns. The orbit becomes unstable. Seasons destabilize. Temperatures swing violently. 2. The moon escapes. Earth and moon hold each other in a gravitational dance. If gravity fails for 10 seconds, the moon drifts just far enough that when gravity returns, it does not return to its orbit. It becomes a slow runaway, a pale ghost drifting outward forever. 3. Tides collapse and explode. Ocean tides are sculpted by the moon. If the moon disconnects even slightly, tides become chaotic. Entire coastlines transform. 4. Earth's core wobbles. The rotation of the planet depends on mass distribution. If layers shift during weightlessness, the core's rotation could misalign. The magnetic field could buckle. Radiation would leak through. 10 seconds is the difference between disaster and uninhabitable. 1 second gave the planet a bruise. 10 seconds would give it a wound. A minute would give it death. But that is not today's story. Today's story is 1 second. A cosmic blink. The scientific impossibility of a flickering universe. Gravity is not like electricity. It does not turn on and off. It does not flicker like a candle. It does not weaken when the lights go out. Gravity is the shape of space-time itself. To turn off gravity would mean to flatten space-time entirely. every curve, every well, every dip that holds planets, stars, and galaxies together, all gone. But science has a few ideas, small cracks along the edges of understanding where impossible phenomena might briefly exist. Let's enter them quietly, gently, one by one. Theory 1. Quantum space-time blink. At the smallest scales, the Planck scale space-time might not be smooth. It might be grainy, pixelated, made of tiny, discrete atoms of space that we can't yet detect. If one pixel failed, the way a cell in an LCD screen flickers, gravity might momentarily misbehave. Not everywhere, but locally. In a region, around a planet, around Earth, around you. This is only a theory, but it is not impossible. The universe may have texture. Theory 2. A passing topological defect. N. Long ago, during the birth of the universe, space-time froze into place like cooling metal. But metal does not cool smoothly. It forms defects, edges, lines, walls. The early universe may have made the same mistakes. Cosmic strings, domain walls, textures. If one of these relics passed through Earth, gravity might have blinked as we crossed its boundary. The universe may be littered with scars from its own creation, and we may have brushed against one. Theory 3. An ultra-powerful gravitational wave. Gravitational waves bend space-time like ripples on a deep cosmic ocean. Normally, they are faint, soft, barely noticeable. But if a wave of unimaginable magnitude passed through Earth, from the merger of black holes larger than galaxies, space-time could distort so violently that gravity fails locally, not truly off, but warped into temporary chaos. Like a cosmic heartbeat so strong, it shakes the fabric of space. Theory 4. Manipulation by advanced life. Not aliens, as Pulp Fiction imagines them, but a civilization millions of years older. A species that mastered space-time like clay. Engineers of gravity. Sculptors of dimensions. To them, turning gravity off for 1 second would be like flipping a switch. A test. An experiment. A message? Or even an accident. The universe is ancient. Humanity is not. We cannot assume we are the first to touch science. Theory 5. Failure of the Higgs field. Mass exists because the Higgs field gives particles weight. If the Higgs field rippled or momentarily weakened, everything with mass would behave differently. Gravity would respond differently. The world would feel briefly. It would be the ultimate cosmic glitch. A moment where reality forgot how to be itself. The global investigation. When the world recovers, every scientist alive will chase the same question. What happened? GPS satellites will show micro-deviations in orbit. Ocean buoys will record patterns no storm can explain. Seismographs will show identical signatures across continents. Air traffic control will report aircraft that floated before falling. Video from every angle will show humans rising from the ground like seeds caught in an invisible tide. For the first time in history, the entire world will share the same mystery, and the answer will not come easily. the return of fear. Even after the damage is repaired, even after buildings are rebuilt, even after oceans settle, the psychological scar remains. People will look at the sky differently, not with comfort, but with a quiet of loud, free, of lined, lingering question. Will gravity do it again? Parents will keep children indoors on anniversaries of the event. Pilots will become superstitious. Cities will have gravity shelters, reinforced rooms designed for sudden weight return. New emergency protocols will be written. The world will imagine future flickers, the way we imagine earthquakes or storms. Humanity will develop a new phobia, the fear of the fall that begins with rising, the awakening of wonder. But fear, something else awakens, something older, something deeper, wonder. Because, for 1 second, humanity experienced what astronauts feel beyond Earth. You floated. You tasted the dream of weightlessness. You felt the universe without gravity's hand. You glimpsed how fragile the rules of reality truly are. And, in that moment, you were part of something vast, something ancient, something cosmic. The universe blinked, and you blinked with it, and Aspia. The world thinks the danger is over. Gravity has returned. People have fallen back to Earth. The sky has resettled. The oceans have calmed. But gravity is not a simple switch. It is not a lamp that can flicker without consequence. It is the curvature of space-time itself, a geometry that binds the universe. And for this here in the Dispral, Thingal Intelliu non. And when something so fundamental flickers, even for 1 second, the aftershocks ripple outward through existence. The event is over, but the aftermath has only begun. You are living in the echo of a cosmic glitch, and the universe is still ringing. The invisible aftershock. Seismographs around the world continue humming minutes after the gravity flicker. They record not just landquakes, but atmoquakes, the violent oscillation of an entire atmosphere slamming back onto the Earth. Ocean sensors capture pressure spikes unlike anything on record. Deep-sea probes rise and fall on currents created not by weather, but by the sudden collapse of suspended water. GPS satellites drift, just slightly, just enough to suggest that the Earth's trajectory, its very orbit, has changed by centimeters. But that is enough. In orbital mechanics, a centimeter is destiny. A centimeter today is kilometers a year from now. A centimeter is the difference between stable and unstable. The first signs are tiny, barely noticeable. But, to scientists, they are terrifying. The first month. By the end of the first month, 3 global anomalies appear. Each one small, each one quiet. Each one, a fingerprint of a universe that was interrupted. 1. Seasons shift by seconds. Astronomers detect that solstices and equinoxes occur slightly ahead of schedule. Not minutes, not hours, seconds. But seconds matter. They imply orbital drift. The Earth is no longer moving around the Sun exactly as before. Its path changed during the flicker, nudged into a slightly different curve. The Sun's gravity recaptured Earth instantly. Yes, but not perfectly, not seamlessly. The orbit has been rewritten by less than the width of a human hair. But that is enough. 2. The moon wobbles. The moon's orbit shows a tiny, unnatural precession. Its distance varies more erratically than before. Its tidal patterns form strange, asymmetric harmonics. Tides no longer follow their ancient rhythm. Some coastlines experience unseasonal surges. Others see unusually weak tides. The change is subtle, but growing. 3. The magnetic field flickers. During the gravity glitch, Earth's molten core shifted. Barely, but it shifted. And when the core shifts, the magnetic field responds. Aurora appear at unusual latitudes. Magnetometers detect sudden dips. Communication satellites encounter interference. Gravity flickered. Earth trembled. Its core danced. And now the field surrounding the planet whispers of the disturbance. The human heart remembers. Most people believe life has returned to normal. They walk. They eat. They sleep. But deep inside, their bodies remember the rise and the fall. Gravity is not just an external force. It shapes physiology. It sculpts the body. Every organ evolved under its constant pressure. When gravity vanished for 1 second, the body felt it. And that memory lingers. 1. The bones ache. Not from breaking, from change. Microstructures inside bone shifted under momentary weightlessness. Not enough to cause disease, but enough to cause a sense of odd, untraceable discomfort. A ghost of weightlessness. 2. Balance disorders spike. Hospitals quietly report a rise in vertigo. Not catastrophic, just strange. Subtle dysfunction in the vestibular system, the inner ear caused by the sudden absence of gravitational reference. 3. Sleep becomes distorted. Dreams grow vivid. People report falling dreams, floating dreams, dreams of ascending into dim skies. Some experience hypnic jerks stronger than they ever have. The brain remembers. The mind remembers. Cells remember. A species raised under gravity has tasted a moment without it. And part of the brain cannot unlearn that memory. Scientists search for a cause. The best minds assemble. Astrophysicists, particle physicists, gravitational theorists, cosmologists, quantum field experts. Even philosophers are invited. They study every aspect of the flicker. They search the Earth. Maps of gravity, gravimetric surveys, show a faint 18.6 global anomaly, as if Earth temporarily inflated by a millimeter and then settled again. They search the moon. Laser reflectors left by Apollo astronauts reveal a slight abnormal shift. They search the sun. Helioseismology shows a momentary disruption in the sun's acoustic modes. As if the flicker rippled through the solar system like a silent wave. They search the cosmic background. The microwave background appears unchanged, meaning the event was local, within the solar system, or worse, around Earth. This is the most unsettling possibility. Gravity flickered, but only here. Why? What singled out Earth? There is no answer. Not yet. Theories multiply like stars. Dozens of theories emerge. Some terrifying. Some beautiful. Some impossible. Some poetic. But 5 rise above the noise. 1. The space-time ripple hypothesis. A gravitational wave of unprecedented magnitude passed through Earth. Something unimaginable, like 2 supermassive black holes merging in another universe. Their collision ringing through dimensions. But there is no known source. No signal. No afterglow. Just silence. 2. The quantum vacuum unpinning event. The vacuum of space is not empty. It is a seething ocean of virtual particles. If this ocean fluctuated violently for one moment, gravity might have slipped, as if the foundation of space-time cracked for a breath. But no known physics allows this. 3. The Higgs field distortion. If the Higgs field wavered, even for a microsecond, mass would fluctuate. Gravity would behave unpredictably. This would imply space-time itself is unstable. Scientists quietly hope this theory is wrong, because the alternative, that everything can flicker, is too profound. 4. A topological defect encounter. A cosmic string or domain wall passed through Earth, a relic of the early universe. If such an object exists, it carries unimaginable energy. It would cause exactly the kind of event Earth experienced, but none have been detected before. And the odds of one hitting Earth are near zero. Near zero, but not zero. 5. The artificial distortion theory. Not aliens, not science fiction, but the possibility that an ultra-advanced civilization capable of manipulating space-time metrics performed an experiment or triggered an unintended side effect. A civilization millions of years older than humanity would have physics indistinguishable from magic. They might not even notice that their experiment nudged Earth. Or perhaps they did it intentionally. A test, a signal, a warning, or a simple mistake. This theory is controversial, but it grows popularity online. People want meaning. People want agency. People want to believe someone is responsible, even if that someone is cosmic. The atmosphere remembers too. The atmosphere is sensitive, more sensitive than humans realize. And the gravity flicker left scars hidden in its behavior. A month after the event, meteorologists detect anomalies, unusual jet stream oscillations. Winds meander in patterns never seen before. High-altitude currents sway like loose threads. Storm tracks shift subtly. Strange temperature inversions. Layers of air switch positions. Warm air rising too high. Cold air diving too low. As if the atmosphere's memory of up and down briefly scrambled. Pressure pulses. Barometers record faint echo pulses. Waves of pressure returning at intervals that match the timing of the gravity flicker. The atmosphere is ringing, like a bell struck by a cosmic hammer. The oceans hold their own memory. The oceans are vast, heavy, deep, but they are not immune to trauma. A gravity lapse, even 1 second long, affects them profoundly. Deep ocean shockwaves. Sensors detect ripples moving through the abyss that cannot be linked to earthquakes or volcanic activity. These are pressure waves created by water collapsing after rising against its nature. Thermocline disruptions. Layers of warm and cold water scramble, mixing in ways that alter nutrient flow. Marine life notices. Migration patterns shift. Whales dive differently. Plankton blooms appear out of season. A persistent global resonance. The oceans vibrate at frequencies slightly altered from before. Barely perceptible, but measurable. As if the seas are humming a new note taught to them by the flicker. The world waits for an answer. Governments publicly insist there is no danger. Privately, they demand daily reports from physicists. Scientists work without rest. Satellites are recalibrated. Particle accelerators run non-stop. Telescopes scan the skies for anomalies. And ordinary people, they wait, they hope, they fear, they check the ground when stepping outside, just to be sure it is still there, still pulling, still loyal, still constant. But the question remains, what if it happens again? And deeper still, what does a universe look like where gravity can fail? The world lies awake at night, wondering if the next flicker will be 1 second, or 10, or more. For now, gravity holds, but the memory remains, and the sky feels just a little bit less trustworthy. Night falls differently after the flicker. People notice it in small ways first. The way shadows stretch. The way air feels heavier near the ground. The way silence deepens after midnight. The world looks the same, but it feels as if gravity, the oldest companion humanity has ever known, has become unreliable. A friend who disappeared once, and therefore might disappear again. Fear becomes quiet, but persistent. A background hum in the mind. Yet, beneath everything, something deeper is moving. A change in the way humans relate to the universe itself. The flicker did not just disturb the earth, it disturbed trust. The second month, a subtle shift in reality. 2 months after the event, scientists detect something they hoped would not appear. A small, persistent gravitational anomaly. Not dangerous, not growing, but present. Like a bruise on space-time that refuses to heal. They call it the persistent gradient. The anomaly is tiny, far too small for humans to feel directly. But precise instruments detect a slight asymmetry in gravitational pull. Depending on altitude, gravity is very slightly stronger at sea level than it should be, and very slightly weaker at high altitude than expected. It is as if gravity has tilted, just a fraction, as if the curvature of space-time was bent and never fully straightened. The effect is so small that only machines feel it. But machines do not lie. Humanity has entered a world where gravity is not exactly what it was before. The return of odd dreams. People everywhere continue reporting vivid dreams. Not just dreams of floating and falling, though those are the most common, but dreams that feel strangely shared. Dreams of rising into dim skies, Dreams of drifting through soft darkness. Dreams of the moment gravity let go. It is as if the collective unconscious is replaying the event, processing it, rehearsing, preparing. Sleep researchers discover something extraordinary. During REM sleep, more people than ever experience microgravity illusions, the sensation of being weightless. This is not random. It is the brain practicing for the unexpected, rewriting its sensory maps, quietly training itself to understand a world where gravity is not certain. Humanity is adapting to a universe that blinked. A new branch of physics emerges. Within months, universities create a new discipline, transient gravitational phenomena, dedicated to the study of episodic gravity failure. Its first generation of researchers are young, curious, driven by the biggest scientific question in centuries. Is gravity fundamentally stable? If not, what does that mean for the future of the universe? Students study orbital mechanics alongside quantum field theory, astrophysics alongside cosmology, and even neuroscience. Because the human experience of gravity is just as important as the physics. For the first time, gravity is understood not just as a constant, but as an event. Something that can act, something that can fail, something that can return. The idea is heretical, but thrilling. Gravity is dynamic, not static, alive. In a way, culture responds. The rise of the secondless moment. Artists embrace the flicker. Like a global muse, painters depict weightless cities. Musicians compose symphonies that rise and fall, as if pulled by invisible tides. Dancers choreograph movements that imitate floating, collapsing, floating again. A new form of poetry emerges. Gravity poetry, where lines drift, stagger, slide downward or upward across the page. Film directors build entire genres around the fragility of physics. Writers describe universes where gravity is not a law, but a visitor. The flicker becomes mythologized, romanticized, feared, worshipped. Some call it the secondless moment. The second that betrayed time itself. The second that felt outside of history. The second that broke the rules. Cultures create rituals around it. Moments of silence, where people reflect on their lives. Under the thin veil of gravity, humanity is living in the dawn of a new cosmic awareness, a global psychological shift. People change in subtle ways. 1. Children become obsessed with the sky. They watch clouds with reverence. Some refuse to be alone outdoors. Others jump from small heights, just to feel the memory of rising. Parents try to reassure them, but reassurance feels fragile. 2. Anxiety rises quietly, not severe enough to cripple society, but enough to alter speech patterns. People say things like, "I hope gravity holds today," as a joke. But the joke carries weight. 3. A strange calmness fills the nights. After the flicker, people spend more time looking upward. There is a softness, in the way they speak of the cosmos. A new humility, a new awe. The human psyche has been reset, recalibrated, retuned to the frequency of the universe. Religious interpretations. Every religion on earth reacts. Some call the flicker a sign. Some call it a warning. Some call it a test. Some call it the result of spiritual imbalance. Mystics argue that humanity momentarily entered a higher state, a realm where laws do not bind, where souls float freely, where the universe reveals itself as dreamlike. A few extreme groups worship weightlessness as enlightenment. Some try to induce it through rituals, meditation, stargazing, extreme fasting. Others fear it. They see it as a cosmic admonition, a reminder of fragility, a divine shake, a whisper. You are not in control. But amidst these reactions, one new movement emerges powerfully. The Order of the Flicker, a spiritual tradition centered not on fear, but on curiosity. They teach the universe is alive. Laws are not absolute. Reality is flexible. Humanity witnessed its first cosmic breath, and that breath revealed our smallness, but also our belonging. Their gatherings are peaceful, slow ceremonies under starlight, where people float in sensory tanks, imagining the moment the world lifted. They do not preach. They wonder. Humanity becomes contemplative in a way it has not been for centuries. The geological response. Earth's crust shifts. Geologists discover cracks in the planet that formed on the day of the flicker. Not from tectonic pressure, not from earthquakes, from gravity absence. When gravity vanished, the crust rose, microscopically, but measurably. When gravity returned, the crust slammed back onto the mantle. This left scars, thin fractures that span continents. A new class of seismic data appears. Gravity quakes. They are not caused by plates shifting, but by the Earth adjusting to having briefly lost its own weight. This is new. This is profound. Earth remembers. The planet itself remembers. The sky begins to misbehave. 3 months after the flicker, astronomers observe something subtle. Stars near the horizon twinkle differently. Not more, not less. Just differently. Light from certain angles bends, in a way inconsistent with pre-flicker measurements. The air is unchanged. The telescopes are unchanged. The stars are unchanged. But the gravitational lensing effect, the bending of light due to gravity, is ever so slightly altered. This means space-time curvature around Earth is not exactly what it used to be. Gravity returned, but not quite the same shape. The universe blinked, and when its eyes reopened, the world was not precisely where it left it. The second flicker theory. Some physicists begin whispering about a new possibility, a terrifying possibility. What if the flicker, but a precursor? What if gravity is entering a phase of instability? What if the universe is approaching a transition, In its fundamental structure, theories emerge. Gravity might oscillate. Gravity might fluctuate in cycles. Gravity might be decaying. Gravity might be interacting with another dimension. Gravity might be responding to dark energy. Gravity might be evolving. At first, these ideas are considered fringe. Speculation. Mathematical indulgence. But then a team in Japan detects a microanomaly in the gravitational constant, a change too small to affect daily life, but too large to be noise. And suddenly, theories that once seemed absurd enter mainstream discussion. The flicker may not have been a freak occurrence. It may have been the first note of a cosmic melody. A planet holds its breath. Months pass. The world waits. The universe is quiet. Too quiet. Gravity holds steady. But trust does not return. Not fully. Not yet. Humanity lives in a strange new era. A time defined not by what happened, but by what might happen again. Children born after the flicker grow up in a world where gravity is not just a law, but a question. Scientists listen to space-time, like doctors listening to a heartbeat. Poets write of floating cities. Musicians compose weightless symphonies. Dreams become more cosmic. Night skies feel more alive. Humanity has entered the age of unstable reality. The universe remains silent, but silence itself can feel like a message. Gravity failed once, and the world knows it could fail again. For now, gravity holds, but the memory of the flicker hangs in the air, like a breath the cosmos has yet to release. Humanity waits. The sky watches, and the next chapter is still unwritten. Gravity has returned, but weightlessness is not something the world forgets easily. Once a body, a planet, a species has risen even for a fraction of a second. The memory becomes part of existence, a new thread woven into the fabric of life. The Earth now moves through space with a quiet bruise in its orbit, a tiny scar, invisible to the eye, but felt in the numbers that astronomers watch late at night. Humanity, too, carries its own bruise, in bones, in balance, in dreams, in the way people now look up at the sky, as if it might loosen its grip again. And the universe carries the greatest bruise of all, because something strong enough to make gravity flicker leaves a signature deeper than any crater, any ripple, any star collapse. Part 3 begins with the world learning to live. In the aftermath of a law that proved it could break, evidence in the air. Months after the flicker, research stations in the upper atmosphere begin reporting oddities. Subtle, soft, barely perceptible, but real. 1. The stratospheric drift. High-altitude balloons detect a micro-shift in atmospheric layering. The stratosphere sits slightly higher than before the flicker, not by meters, by millimeters. But this should be impossible. Gravity determines atmospheric thickness. If the stratosphere is higher, the atmosphere is still relaxing. From being momentarily unbound, it is like dough that rose once and refuses to flatten the same way again. 2. The helium escape spike. Helium, a light gas, now escapes into space slightly faster than before. The increase is small, but statistically undeniable. It's as if the upper atmosphere briefly expanded enough to ease helium past Earth's gravity well, like a window was cracked open. 3. The twilight shift. Twilight light curves, the scattering patterns of sunlight through Earth's atmosphere, change subtly. Photographers notice first, then scientists confirm it. The sky has a slightly different shade in the minutes after sunset than before the flicker. The atmosphere is not what it was. Gravity returned. But the sky remembers its moment of release. The geological memory. Deep within Earth, the crust continues adjusting. Slowly, quietly, like metal cooling after being heated, but from the inside out. 1. Microlifts in the crust. GPS stations across continents detect tiny elevations, fractions of millimeters, appearing randomly, then stabilizing. The crust is shifting to compensate for the moment it lost its own weight. Some mountains rise imperceptibly. Some fields tilt just slightly. It is not dangerous, but it is unnatural. 2. Cavern reverberations. In deep cave systems, sensitive microphones pick up long, low-frequency vibrations. Not earthquakes, not water flow, not wind. The earth is humming, a resonance caused by the sudden compression. When gravity returned, it is a song of memory, a subterranean echo of the moment the planet floated. 3. A new tectonic rhythm. Seismologists discover that Earth's natural frequency, its background vibration, has shifted by a fraction. This frequency is the planet's heartbeat, and it changed. After the flicker, Earth is alive in a new way. Or perhaps it has always been alive, and the flicker made that life visible. For the first time, the fluids that remember, water, more than anything, remembers motion, remembers interruption. During the flicker, the oceans rose a millimeter. Lakes domed like glass. Rivers loosened from their beds. When gravity returned, water collapsed downward, and the collapse was not clean. 1. Long waves that should not exist. Oceanographers detect slow, low-frequency waves circling Earth's oceans. They do not match tides. They do not match winds. They do not match storms. They match only one event: the gravity glitch. The oceans are still ringing with the memory of falling back to Earth. 2. Thermocline inversion. Layers of warm and cold water remain slightly misaligned. This disrupts marine migration. Some species dive deeper. Others rise earlier, as if confused. by a new internal compass. 3. Microbubbles in deep water. Strange microbubbles are found in regions of deep ocean, where bubbles should collapse instantly under the crushing pressure. These bubbles are remnants, tiny pockets of water that briefly lost their own weight and regained it suddenly. They are trapped memories, little fossils of weightlessness, anomalies in human biology. Human bodies are exquisitely sensitive to the invisible forces of nature. Even if you did not feel weightlessness directly, your cells did, your organs did, your sensory systems did, and some of those effects linger. 1. The gravity shadow effect. Doctors begin observing a strange pattern. Some people feel brief lightness waves, especially when standing up. A momentary sensation that gravity loosened by a fraction. This is not gravity changing again. It's the nervous system replaying. The flicker. The brain stores gravitational memory the same way it stores trauma. 2. Subtle heart rhythm variations. During the flicker, blood experienced a sudden redistribution. For 1 second, the heart pumped into near weightlessness. A microscopic fraction of people develop long-term rhythm shifts. Not harmful, just different. Their hearts beat as if gravity is slightly less inevitable. 3. Sleep drift. Sleep researchers find that REM cycles have shifted globally. By a small but measurable percentage, people enter REM slightly earlier than before. This is remarkable. The flicker changed how the brain transitions into dreaming, and with that shift comes a transformation in the nature of dreams themselves. The dream phenomenon. Dreams become the doorway to the deeper psychological memory of the flicker. After the event, millions of people report the same kinds of dreams, floating upward, drifting sideways, being suspended in soft darkness, watching objects rise, feeling the world loosen. But then the dreams change. They become stranger, more vivid, more interconnected. Scientists notice patterns. 1. Collective dream imagery. Across cultures and continents, people dream of weightless oceans, cities lifting into the sky, soundless falling, a thin, bright line in the darkness, and a pulse, a cosmic heartbeat felt through the air. It is as if humanity has unlocked a shared dream, a subconscious map of the gravity flicker. 2. The ascension dream. A specific recurring vision emerges. You rise slowly. The world stretches beneath you. Gravity loosens. Then everything freezes. A perfect stillness. Before falling all at once, people wake gasping. It is the flicker replayed, but dramatized by the mind's instinct for symbolism. 3. The stranger dreams. Some dream of space-time rippling like water, invisible walls, impossible landscapes, gravity bending as if alive. Beings moving in weightless corridors, tunnels through the dark, alternate Earths where gravity fails frequently. These dreams align eerily with advanced gravitational theories that most people have never heard of. It's as if the flicker unlocked a deeper intuitive sense of the universe, or as if the subconscious knows something the waking mind does not. Anomalies in time itself. One of the most unsettling consequences of the flicker is discovered only months later. Atomic clocks recorded a microsecond distortion, a tiny pause, a ripple in time, a moment where time was not perfectly smooth. This is enormous. This means the flicker was not purely gravitational. It was temporal. Gravity and time are intertwined. When gravity changes, time stretches or compresses. This is known, well understood, predicted by general relativity. But the flicker was not predicted. It was not expected. It was not gentle. It was a break, a rupture, a single second that bent the flow of time like a wave. And because time flows forward, this wave left no afterpulse, just a subtle, permanent offset in the tick of the universe. Physics is forced to face an impossible truth. The universe experienced a moment of imperfect time. The international response, quietly, without public announcement, the world's major powers create a classified coalition, the Global Gravitational Stability Initiative, GAGSI. Their mission: detect future flickers, understand the cause, model the consequences, prepare emergency protocols, search for precursors, search for a pattern, search for signs that it will happen again. Because the nightmare scenario is simple. A flicker lasting longer than 1 second would break the world. GGSI builds gravity early warning systems, synchronized atomic clock networks, orbit monitoring satellites, ocean pressure grids, atmospheric scanners, space-time distortion cameras, deep Earth resonance monitors. Earth now behaves as if living under a threat no one can see. Humanity is monitoring gravity with the same urgency once reserved for nuclear weapons. The quiet fear in everyone. No one admits it openly, but everyone knows. The flicker was not an ending. It was a beginning. People glance upward at random moments, checking subconsciously. If the world feels lighter, children ask, will the sky turn off again? Adults laugh, but with tension behind their smiles. Airline passengers grip their armrests a little tighter during takeoff. Farmers watch the movement of dust on windy days to reassure themselves it is still falling downward. Trainers teach athletes to steady themselves in case of unexpected gravitational irregularity. It becomes part of culture, part of language, part of the collective emotional landscape. Gravity, once unquestioned, is now a character in the story of human vulnerability. A species changed forever. And so, part 3 ends with the world altered, not destroyed, not suffering, not broken, but changed. Humanity has stepped into a new age, the age after trust, the age after certainty, the age after gravity proved it could fail. People continue to live, work, laugh, dream, but always with the quiet knowledge that the world is lighter than it seems, more fragile than they imagined, more mysterious than they were taught. Gravity is holding, but memory is powerful, and the memory of the flicker will shape humanity's future in ways no one yet understands. The universe blinked once, and now the world waits to see if it will blink again. The world has grown quieter since the flicker, not in sound, but in spirit. There is a calmness in the air, the kind that settles after a great storm. When nature pauses to remember what happened, birds still fly, clouds still drift, wind still curls across empty fields, but everything moves with a slightly different rhythm, as if the world is relearning how to breathe under the weight of gravity that betrayed it once. Part 3 continues with the deeper consequences that linger in Earth's systems, in human culture, in the minds of scientists, and in the quiet, trembling fabric of space-time itself. The emergence of shadow gravity. 6 months after the flicker, a peculiar anomaly appears, a faint gravitational echo, recorded only by the most sensitive instruments, a secondary gravitational softness, trailing after objects in motion, like a shadow, but made of gravity, a ghost field, a remnant, a smear in space-time, left behind by the flicker. It does not affect daily life. It is incredibly weak, but measurable. Physicists call it shadow gravity. No one agrees on what it means, but 3 theories rise to prominence. 1. Memory field theory. Gravity, like a fabric, can be stretched and twisted. Perhaps the flicker created wrinkles that take months or years to smooth out. 2. Space-time stress residue. Like metal bent suddenly, space-time now holds stress patterns, visible as faint gravitational echoes. 3. Dimensional overlap. Some theorists dare to suggest that the flicker briefly thinned the membrane between our universe and another. If gravity is a cross-dimensional phenomenon, the flicker might have temporarily aligned 2 gravitational fields, and the echo is the fading remains of that alignment. It is speculative, but the universe is stranger than imagination allows. Animals sense what humans cannot. In forests and deserts, in tundra and coral reefs, in cities and mountains, animals begin showing unusual behaviors. Biologists observe patterns. 1. Birds fly lower, as if wary of something above them, as if the sky is not trustworthy, as if an ancient instinct is warning, do not rise too high. 2. Whales alter their navigation routes, slightly, curving away from certain ocean regions, as if they sense deep pressure variations caused by the flicker's aftershocks. 3. Insects cling harder to surfaces. Tiny legs grasp with more instinctive urgency, a microscopic echo of the moment. Gravity vanished. 4. Cats behave strangely during certain nights, looking upward, following invisible changes in air pressure, listening to vibrations humans cannot detect. Animals feel Earth's memory. Their bodies evolved with gravity as a constant rhythm. Now the rhythm has faltered, and they sense the tremor that continues below perception. Humanity studies the world through machines. Animals study it through instinct. And their instincts say that something is still shifting. The subtle consequences in technology. The flicker did not destroy infrastructure, but it changed physics just enough to introduce strange side effects. 1. Clocks drift in unusual patterns. Atomic clocks, the most precise instruments humanity has ever built, show micro-variations that follow a strange, global rhythm. Not quite a cycle, not quite random, like breathing, a slow inhale and exhale in the flow of time itself. Scientists give it a name: time drift harmonics. Time is no longer perfectly smooth. It carries a vibration, a signature, a reminder. 2. Gyroscopes lose absolute precision. Aircraft instrumentation shows a tiny, oscillating deviation. It does not endanger flight, but it proves that inertial reference frames are not entirely stable. After the flicker, spacecraft navigation systems require frequent recalibration. Engineers blame solar radiation, then atmospheric noise, then thermal drift. But secretly, they know the truth. Space itself is not exactly how it used to be. 3. Gravitational sensors detect ghost movements. Ultra-sensitive detectors pick up faint fluctuations, not tied to mass, motion, or vibration, as if something invisible passes through Earth at irregular intervals. No one understands them, but they are becoming more frequent. The scientific schism. A philosophical divide spreads among physicists. Two schools emerge. The stabilists, those who believe the flicker was an isolated anomaly, a chance event, a once-in-a-billion-year occurrence that will never happen again. They argue for caution, but not fear. The metastability theorists, those who believe gravity is not actually constant, that the universe is entering a new phase, that the flicker was the first sign of a large-scale structural shift in space-time. Their idea is dangerous, because if they are right, the laws of physics may be in transition. The debate becomes heated, emotional, existential. For the first time in centuries, science feels divided, not by data, but by worldview. Humanity stands on the edge, between certainty and unknown, and scientists must decide which way they lean. Human culture evolves. The psychological impact of the flicker deepens into culture. 1. Architecture changes. Buildings adopt new structural guidelines. Designs include stabilization systems meant to counter sudden changes in gravitational load. Skyscrapers incorporate gravity dampers. Houses feature reinforced frames. Bridges gain new calibration monitors. Engineers do not trust gravity the way their predecessors did. 2. Art embraces cosmic instability. Painters depict floating cities. Dancers perform movements that mimic rising and falling in slow motion. Writers explore stories of worlds where gravity is seasonal. Music drifts with long, sustained tones that resemble weightlessness. The flicker reshapes creativity. 3. Languages shift subtly. New phrases emerge. Hold steady. Sky willing. Trust the pull. When the world holds tight, humans adapt not just physically, but linguistically. An unsettling discovery in deep space. A year after the flicker, astronomers detect something that changes everything. Light from a distant quasar arrives distorted in a way that matches the gravitational flicker signature. The distortion is exactly the same pattern observed on Earth the day gravity failed. But the quasar is billions of light years away. This means the flicker was not local. It was not caused by Earth. It was not caused by the solar system. It was not a random glitch. The signature exists elsewhere in the universe. Far, far, far away. This leads to one terrifying possibility. Gravity is failing in multiple locations, not collapsing, not vanishing, not breaking, but flickering, like a cosmic system, overloaded, stressed, glitching. The universe might be unstable in ways humanity never knew. The flicker was a warning. Scientists analyze the quasar data and realize something profound. The flicker signature is traveling, a gravitational shockwave, moving across the cosmos at the speed of light. Earth was simply one point on its journey. The next flicker might arrive in years, or centuries, or tomorrow. But one conclusion becomes unavoidable. The flicker was not the cause. It was the symptom. Something enormous happened billions of years ago. Something powerful enough to distort space-time. Across the universe, a gravitational wound, still healing, still moving, still affecting everything it touches. Earth was brushed by the edge of a cosmic scar, and the universe holds many scars. The night sky feels different. As humanity processes the discovery, people begin spending more time watching the stars, not out of fear, not out of despair, but out of wonder. The night sky feels deeper now, more layered, more alive, as if gravity itself is whispering secrets through the pull of the universe. People begin to understand a quiet truth. The sky is not empty. It is full of unseen currents, hidden tides, cosmic rhythms, symphonies of bending space-time, and humanity has finally noticed. The flicker was a revelation, a reminder of how fragile and extraordinary existence truly is. The chapter closes, but the story does not. Part 3 ends with the world transformed. Scientifically, culturally, emotionally, gravity holds, but trust does not. Not fully. Not yet. The universe feels closer, more intimate, more mysterious, as if humanity is finally hearing the quiet breathing of space-time. The flicker may not happen again for 1,000,000 years, or it may happen in the next heartbeat. The world is watching, listening, waiting. Gravity is steady today, but tomorrow, the universe alone knows, and the sky is a little quieter than it used to be. The universe has always seemed steady, not gentle, not kind, not safe, but steady. Stars burn, galaxies rotate, planets orbit, gravity pulls. It is the one story we thought would never change. But then, for 1 second, gravity failed. And now, in the deep quiet after that cosmic blink, the universe begins to show that it is not done with us yet. Part 4 is not about the moment gravity failed. It is about the slow realization that the universe itself is entering a new chapter. A chapter humanity did not ask for, but must learn to live in. The discovery that changes everything. The quasar data was only the beginning, a pattern hidden in light that had been traveling toward us for billions of years. Now, more signs appear. Other galaxies show the same strange distortions, the same flicker signature, the same gravitational scar. Not everywhere, not in all directions, but in a chain, as if something enormous, ancient, and powerful moved through the universe long ago, leaving behind a corridor of altered gravity, and the solar system just happened to fall across its path. Astronomers map it carefully, like charting the path of a storm that has already passed through, but still leaves aftershocks. They call it the gravitational corridor, a cosmic scar, a path across the sky where space-time has been stretched thinner than elsewhere. Earth sits near its faint, fading edge. We were not the target. We were collateral. What could have done this? Theories emerge again, but this time they are sharpened by the shape of the corridor. This was not random. This was directional. This was movement. Something traveled. Something interacted. Something passed through the universe. like a slow, invisible tsunami of gravity. 4 candidates rise to the top. 1. A line of merging black holes. Perhaps, in the young universe, a chain of supermassive black hole mergers occurred one after another, each generating gravitational waves that overlapped into a massive corridor of distortion. The combined effect could have altered space-time over hundreds of millions of light years, but no known simulations predict a pattern like the one we see. This explanation fits the data only halfway. 2. A primordial defect in space-time. If the early universe formed with a giant topological defect, a wrinkle in space-time, its slow motion could carve a corridor as it drifts through the cosmos, a domain wall, a seam in reality. Passing through such a wall could briefly change gravity's behavior. Earth may have just crossed the cosmic equivalent of a boundary between phases of space-time, but that implies there are regions of universe with different rules, and that is a terrifying thought. 3. A dark energy phase ripple. Dark energy, the mysterious force accelerating cosmic expansion, may not be uniform. It could have undergone a rapid shift. In some distant epoch, the way water suddenly turns to steam if heated past a threshold. Such a phase change could have sent out a wave, a bubble of different space-time density that has been traveling ever since. When that bubble's edge passed over us, gravity flickered. This would mean the universe is not in a stable state. It is evolving, transitioning, becoming something new. 4. A controlled event. The wildest theory is whispered in the darkest conference rooms. Perhaps the corridor is artificial, a deliberate manipulation by a civilization so advanced that its technology operates on the canvas of space-time itself. To such beings, gravity is a tool, a material, a medium. They might have carved a corridor using controlled gravitational distortions, either for travel, communication, or experiments. And humanity, small and unsuspecting, simply drifted into the edge of their wake. We do not know which theory is right, but we know one thing now. The flicker was not just local. It was part of something much larger, much older, much deeper, living in a universe that isn't finished. For most of human history, we believed the laws of physics were timeless, constant, universal, outside of history. Now, we see the opposite. The universe is a process, a work in progress, a structure still settling into itself. Gravity may be stable for billions of years, and then, for 1 second, it wavers, not as a bug, but as a feature. This realization changes how scientists think, how philosophers think, how ordinary people think. The universe is no longer a stage on which events happen. It is a character in the story, growing, changing, responding. And humanity is not just living in it. Humanity is feeling its moods. The mathematics of an imperfect law. In labs and universities, new equations are written. Einstein's general relativity still works. It still describes gravity with astonishing precision. But now, physicists add something new to the mathematics. Tiny instability terms, corrections so small that they don't matter for normal life. But they matter when gravity fails. These new equations suggest that space-time can enter metastable states, like a ball resting in a shallow valley that might one day slip into a deeper one. For now, we are in one such valley. Gravity behaves. Planets orbit. Oceans stay attached. But the flicker, that somewhere, somehow, something pushed the ball. Just a little. Just enough to make us feel it. The new theory doesn't yet have a complete name. Some call it gravitational metastability. Some call it dynamic space-time relativity. Some call it simply post-relativity. But underneath the terminology is a single, unsettling possibility. The laws of physics may not be final. Preparing for the next flicker. Publicly, governments reassure citizens that the flicker was a one-time event. Privately, they assume the opposite. Contingency plans are drawn. New guidelines are created for aircraft, satellites, rockets, even elevators and skyscrapers. There are now international protocols for sudden temporary gravity loss. Engineers design systems that lock in place during weightlessness, then cushion the return of gravity. Hospitals develop procedures for injuries caused by mass freefall and sudden compression. Space agencies design spacecraft capable of surviving a temporary loss of gravitational reference. All of it seems excessive, paranoid, even absurd, until people remember that it already happened once. Once is enough. The quiet shift in human purpose. As the years pass, something subtle blossoms in the minds of people everywhere. A new kind of question, a new kind of longing. Humanity, for the first time, has felt the fragility of its own physical context. And this changes what we dream about. Not just survival, not just progress, not just comfort, but understanding. We want to know what the universe is doing, why gravity faltered, what the corridor is, how deep the changes go. And that desire begins to unify us in a way almost nothing else has. Countries may disagree on politics, territory, economics, but they agree on this. If the universe is changing, we need to understand how. Not later. Now. This leads to the most ambitious scientific project in human history, the Cosmic Sensing Array. It begins with a simple idea. If space-time is now unstable, we must listen to it, not with one instrument or a dozen, but with a planet-sized network, a global web of devices, sensitive to gravity, time, light, mass, pressure, and the faintest tremors in space-time. Together, they form the Cosmic Sensing Array. It consists of deep underground gravity observatories, satellite constellations mapping minute orbital changes, ocean floor pressure sensors, high-altitude time dilation monitors, quantum entanglement baselines for time drift, gravitational wave detectors tuned not just to mergers, but to slow, background fluctuations. The array's purpose is simple. Listen. Listen to the universe, the way a doctor listens to a patient's heartbeat, to detect early signs of major changes, to map the structure of the gravitational corridor, to search for hints that another flicker is coming, or that something even stranger could occur, and the unexpected benefit, a new vision of reality. As the Cosmic Sensing Array matures, science leaps forward by layering gravitational data with electromagnetic observations. Humanity gains a new kind of map, not just of stars and galaxies, but of the shape of space-time itself. We see filaments of dark matter more clearly than ever before, subtle gravitational eddies around galaxy clusters, voids whose emptiness is more structured than we imagined, tiny creases in space-time where ancient gravitational events left scars. This map is beautiful, terrifying, holy. It reveals a universe that is not smooth, not static, not symmetric, but knotted, wrinkled, layered with history. Every galaxy sits in a basin, carved by past gravitational storms. Every cluster is like a coral reef, grown from ancient cosmic tempests. Every void is a silent testament to regions the universe never quite filled. The flicker forced humanity to develop instruments to sense instability. Those same instruments gave us something else, a way to finally see the living structure of the cosmos, the cosmic psychology of a fragile law. Part 4 is not only about physics, it is about how humans change when the bedrock of reality is shown to be fragile. At first, fear ruled, but over time, something calmer grows. A kind of cosmic humility. People begin to understand that certainty was always an illusion. The universe has never been obligated to maintain the same rules forever. We just happen to exist during a long, quiet period of stability. Now we glimpse the edges of something else, and instead of breaking, we adapt. Our stories adapt. Our art adapts. Our science adapts. Our philosophy adapts. We are a species. We are a species built to find meaning in uncertain conditions. And the greatest uncertainty we have yet faced is not death, or time or space. It is the idea that the laws beneath all of these can change. Yet, even in this realization, something peaceful emerges. A feeling that the universe is not a cold machine, not a fixed code, but a vast, unfolding process, in motion, in evolution, in conversation with itself. We are part of that conversation now. The flicker was one of its words. The deeper humanity looks into the aftermath of the flicker, the more the universe begins to resemble a living organism, not in the mystical sense, but in the scientific sense. A structure with rhythms, stresses, wounds, memory, and change. Part 4 continues with the unfolding realization that the universe might not merely contain life, it might behave like something that is alive, something in transition, something shifting its weight. In the dark, gravity did not fail randomly. It failed because something moved, something ancient, something vast, something that is not done moving. The second shadow. A year after the first flicker, gravitational sensors worldwide pick up a faint tremor, not a flicker, not a drop, just a tremor, a soft, almost imperceptible dip in the stability of space-time, like the faraway footstep of a giant walking in another room. It lasts for milliseconds, barely enough for machines to detect, far too short for humans to feel. But it is unmistakable. Another signature from the corridor. This is not the main wave. This is not the scar itself. This is something like an echo, a shadow, a reminder that cosmic events within Taining 2 do not simply happen and then stop. Their effects whisper through space-time. For eons, the tremor triggers intense debate. Some say it means nothing. Some say it is only the tail end of the first flicker. Some fear it signals a second approaching. But one interpretation slowly gains traction. The universe is adjusting, rebalancing, settling, like a body shifting its limbs. After waking from a long sleep, the quiet possibility, a radical theory emerges. Quietly, carefully, shared only among physicists who trust one another's discretion. What if the universe is entering a new gravitational phase? Not collapse, not destruction, not chaos. A transition, a metamorphosis, a shift in the rules governing mass and motion. In particle physics, fields evolve, constants shift, forces unify and separate across cosmic epochs. Why should gravity be immune? Why should gravity be eternal? Why should gravity not change as the universe ages? If this is true, humanity is witnessing the early ripples of a transformation, billions of years in the making, a slow adjustment in the very geometry of existence. The flicker, the corridor, the echo, the tremor, they are not threats. They are signs. signs that the cosmos is stretching into a new shape. The cosmic breath theory. In a late-night conference at the International Gravitational Institute, a small group of scientists introduce a theory that at first sounds poetic, but later proves shockingly viable. The universe breathes. Not literally, not biologically, but structurally. In this theory, space-time expands and contracts in long, slow cycles that take billions of years, like lungs of cosmic fabric, like tides of geometry, like a heartbeat made of galaxies. Gravity does not remain constant. During these cycles, it strengthens, weakens, stabilizes, and flickers as part of a vast pulsation. The flicker we experienced was not a collapse. It was an inhalation or an exhalation, a moment in a cycle humanity has just begun to perceive. If the theory is right, the universe has done this before. It will do it again, and again, and again. Cosmic breathing could explain the gravitational corridor, the quasar distortions, the lingering echoes, the gentle tremor, the atmospheric anomalies, the oceanic resonances, the subtle shifts in time. All of them are symptoms of a universe in motion, not moving through space, but moving as space, a universe that inhales across aeons and exhales across millennia, a universe alive in its own way. The human dilemma. If gravity flicker is part of a cycle, humanity must ask, are we ready to live in a universe that changes? A universe where even the laws are not permanent. A universe where stability is just a chapter, not the whole story. For centuries, we believed we lived under fixed rules. Rules as solid as stone. Rules as eternal as stars. Now we stand on shifting ground, both literally and cosmically. How do we build meaning in such a world? How do we sleep, knowing space-time once misfired? How do we dream when gravity itself once slipped, like a hand losing grip? The answer arrives slowly, gently, like dawn. We adapt. We always have. Humanity has lived through ice ages, plagues, storms, collisions, explosions, extinctions, and eras of deep uncertainty. We adapt, not because we are invincible, but because we are aware. The flicker did not destroy humanity. It awakened it. The future built on uncertainty. From the cosmic sensing array comes a flood of new data. Patterns emerge. Graphs sharpen. Models converge. One conclusion becomes unavoidable. Another flicker will happen. Not soon. Not this century. But eventually, humanity decides to prepare. Not in fear, but in wisdom. New technologies emerge to stabilize artificial gravity for brief periods. Cities add structural buffers. designed to handle sudden loss of weight. Air travel and space travel are redesigned around redundancy and suspension protocols. Schools teach the reality of mutable physics. Philosophy evolves to embrace uncertainty as part of existence. Art shifts toward movement, fluidity, stretched forms, and rising shapes. And people, ordinary people, slowly become comfortable with the idea that nothing is guaranteed except change. The flicker becomes not a trauma, but a teacher, a reminder that the universe we inhabit is vast, alive, and still unfolding. A new kind of peace. You might expect fear to dominate this era, but something else grows instead. Something unexpected. Something beautiful. A sense of cosmic peace. For the first time, humanity truly sees its place, not as rulers of Earth, not as observers of the cosmos, but as participants in a universe that is not finished, a universe that is evolving, becoming, transforming, like us. The flicker was frightening, but it also revealed something profound. We are part of the universe's story, not spectators, not outsiders, not accidents, participants. And once people realize this, fear turns into acceptance, acceptance into curiosity, curiosity into wonder, wonder into peace. Because if the universe can change its laws, shift its weight, waver in its pull, and still hold together, then perhaps we can too. The apocalypse that never arrived. Movies, stories, and old myths. Imagine the end of the world in fire, flood, darkness, impact, chaos. But the flicker was not an apocalypse. It was a whisper, a nudge, a reminder. The universe did not collapse. The planets did not scatter. The stars did not dim. The oceans did not rise endlessly. The ground did not tear open. Gravity merely paused for one delicate heartbeat and then resumed. Gently, quietly, almost embarrassed, as if it had tripped over its own eternal certainty. This is not the end of the world. This is the end of an assumption. The assumption that reality is fixed, that laws are permanent, that we understand. What we live inside, we do not. Not fully. Not yet. But we are learning. The cosmic silence returns. As part 4 ends, things grow quiet again. Not ominously, just naturally. The tremor fades. The echoes settle. The sensors calm. The skies return to their familiar glow. But something is different. Not outside. Inside. Humanity feels the universe now. Feels its motion, its breath, its vulnerability, its complexity, its unfinished nature. When people look at the stars, They no longer see distant suns. They see the architecture of shifting space-time, the currents of gravity, the scars of ancient events, the pathways of cosmic evolution. And somewhere, deep in that vastness, the cause of the flicker continues to move, slowly, patiently, silently, like a giant turning in its sleep. The universe is not done speaking. It is only pausing between sentences. There is a special kind of quiet that only appears after a great unknown. Not after a battle, not after a disaster, but after a question so large that the world has no choice but to grow around it. The gravity flicker was such a question. It was not the end. It was not the beginning. It was a pause, a missing beat in the rhythm of existence. And now, time moves forward again, but not the way it did before. Part 5 is not about the moment of the flicker, or even the years after. It is about the long night that follows, the centuries, the distant futures, the new myths and sciences born from the memory of weightlessness. It is about how a single second can echo across an entire civilization, and how that echo might one day reshape the fate of the cosmos itself. The generation that never felt the fall. Decades pass. The children born after the flicker do not remember it. They know it only through stories, records, measurements, and the quiet tension in their parents' voices. When gravity is mentioned, to them, the flicker is history, like an ancient quake, like an old war, real, but distant. These children grow up in cities, equipped with gravity dampers, stabilization protocols, and emergency fields designed to soften another sudden return of weight. In schools, they are taught about the event, not as a catastrophe, but as a revelation. The lesson is simple. The universe is not finished. They learn about gravitational corridors, cosmic scars, shadow gravity, and the possibility that space-time itself is slowly shifting into a new state. This becomes normal to them. They do not fear it as much as their parents did. Instead, they are curious, intrigued, drawn to the mystery. For them, the flicker is not a trauma. It is an invitation, the new age of exploration. In the centuries before the flicker, humanity dreamed of exploring space for resources, for survival, for curiosity. In the decades after the flicker, a new motivation appears, not just to explore space, but to explore space-time. The gravitational corridor, mapped more clearly over the years, reveals regions where space-time is thinner, stressed, warped by ancient forces. These regions become the new frontier. Exploration missions are launched, not just to planets, moons, and asteroids, but to positions in space, where gravity itself behaves strangely. Humanity builds stations in regions of slight gravitational distortion, observatories at the edges of the corridor. Deep space probes to ride along the gradient. These missions do not search for minerals. They search for answers. What moved through here? What caused the flicker? Is it still moving? Will it return? As probes drift deeper into the corridor, they begin sending back astonishing data. Tiny shifts in time rates, microscopic variations in mass, regions where quantum fluctuations seem amplified. Space-time here is not broken, but it is different. Like glass that was once heated and then cooled too quickly, leaving internal stress. Frozen into its structure. The first gravity shapers. Technology follows curiosity. It always has. As humanity learns more about the corridor, it begins to discover ways to gently, carefully nudge gravity. Not to turn it off, not to wield it like a weapon, just to make tiny adjustments on very small scales. It begins with experiments. Localized reduction of gravitational pull across a meter. Controlled generation of microwells, like artificial, harmless valleys in space-time. Precise manipulation of inertial frames for advanced spacecraft stabilization. These experiments demand enormous energy and incredible precision. They are not casual. They are not trivial. But they work. For the first time, gravity is not just observed, it is touched, shaped, guided. The scientists who specialize in this gain a new name: gravity shapers. They are not magicians, not gods, still subject to the laws they study, but they are the first humans to participate directly in the architecture of space-time. Their work is dangerous, tightly regulated, carefully monitored by the cosmic sensing array. The irony is quiet but clear. Only after gravity failed once did humanity learn how to gently move it. The ethics of touching space-time. With power comes responsibility. With responsibility comes fear. With fear comes debate. As gravity shaping matures, ethical questions rise like distant storms. If we can alter local gravity fields, even slightly, should we? Is it safe to nudge a fabric that holds entire planets in orbit? Is it wise to experiment on a force that once failed on its own? What if our manipulations interfere with the natural process of cosmic transition? What if the universe is trying to rebalance itself and we are in the way? Philosophers of physics begin writing about cosmic consent, the idea that the universe is not just a backdrop, but a partner, that manipulating its fundamental laws without respect is a kind of arrogance. Others argue the opposite. If the universe gave us minds capable of understanding gravity, then perhaps it expects us to eventually guide it. We are part of space-time, not separate from it. Our intelligence is one of its properties. To act is not to intrude. To act is to participate. The debate never fully resolves, but it shapes policy. shapes culture, shapes the way gravity shaping is taught, not as conquest, as dialogue, new ways of living with gravity. As the centuries pass, gravity shaping finds peaceful uses, buildings that adjust their own weight during earthquakes, medical devices that temporarily reduce gravity on specific organs to give rest and recovery, rehabilitation systems that help injured people walk again in tailored gravitational environments, sports played in softly modulated gravity fields where players move as if in a dream, art installations where sculptures float as if underwater, held gently by shaped space-time. People begin to experience gravity not as a single number, but as a range, a spectrum. The universe's oldest constant becomes a variable humans can work with. The flicker, which once terrified the world, gave birth to technologies that make life softer, safer, more beautiful. But the memory of that first failure is never entirely forgotten. It lingers under every invention, a quiet reminder. This began with a second when everything slipped, the long cosmic view, far beyond the lifetimes of those who witnessed the flicker. The universe continues its slow evolution. The gravitational corridor stretches across billions of light years. Its edges diffuse. Its internal stress relaxes. Humans, or whatever humanity becomes, build stations. Deep within it, they study not only how space-time behaves there, but how it feels to live in regions where gravity is innately different. Time passes differently. Mass behaves differently. Quantum fields fluctuate differently. Civilizations arise. In these gravity-modified domains, some choose to live in nearly Earth-like conditions. Others embrace unusual regimes, low-gravity cities, where movement is gentle, dreamlike, like living in perpetual slow motion. High-gravity sanctuaries, where bodies anchor more deeply, muscles grow dense, and people feel profoundly grounded. Variable gravity environments, where daily cycles include periods of weightlessness for meditation, creativity, and altered states of perception. Life diversifies, not just in biology, not just in culture, but in its relationship with gravity itself, and all of it. Every new world, every new way of living can trace its lineage back to a single second when gravity failed, the whisper at the end of time. No law is eternal. No structure lasts forever. Not even the universe itself. In the far, far future, long after stars have burned out, galaxies have drifted apart, and the cosmos has grown thin and cold, gravity remains, weaker, stretched, faded, but still there, binding what little matter is left into remnants, whispers, embers of long-vanished worlds. The flicker, recorded in deep historical data and etched into altered space-time, becomes a point of reflection for whatever consciousness still exists then. Artificial minds, evolved minds, merged minds, distributed across structures larger than galaxies. They will look back on the history of gravity the way we look back on the history of chemistry or the early formation of stars. They will see that the universe did not always hold one form, that it shifted, breathed, faltered, corrected, transformed. The flicker will be recognized as one moment in a grand transition, perhaps a change from a gravity-dominated cosmos to a dark energy-dominated cosmos, perhaps a stage in the evolution of space-time itself, or perhaps, from their vantage point, it will be seen as something else entirely, a signal, a message, a step, something we were too early to fully comprehend. But even if they understand what we could not, our part in the story remains. We were there. We felt it. We floated. We fell. We listened. And we adapted. A strange kind of comfort. In the end, the story of the gravity flicker is not about fear. Not truly. It is about adjustment, about humility, about learning to live in a universe that is more fluid than we imagined. There is a strange comfort in knowing that nothing is absolute. If gravity can change, so can we. If space-time can shift, so can our understanding. If the universe can falter and continue, so can a single mind, a single life, a single species. The flicker becomes a metaphor for grief, for loss, for sudden change, for moments when the ground seems to disappear, and for the fact that life somehow returns. Gravity came back. So did we. In a universe where even laws have their seasons, the real constant is not a number. It is the capacity to adapt, to learn, to wonder, to keep moving, even when the fabric beneath us shifts. And as long as that remains, no cosmic flicker, no gravitational corridor, no metamorphosis of space-time can erase what it means to be alive. Within it, there is a moment after every long night when the universe seems to pause, not because time stops, not because motion ceases, but because awareness expands. The flicker awakened something in humanity, a deeper listening, a quieter curiosity, a sense that the cosmos is not a distant machine, but a vast and shifting ocean that we are swimming in. Part 5 continues with the long arc of civilization's journey. After gravity's 1-second silence, it is here, in the slow unfolding of millennia, that the true meaning of the flicker begins to emerge. The return to stillness. As centuries become millennia, civilizations stabilize. Gravity-shaping technology becomes precise. and safe, integrated into daily life. Most humans, or post-humans, live in environments where gravity has become a chosen parameter rather than a fixed constant. Some choose Earth normal gravity for tradition, comfort, familiarity. Others live in soft, dreamlike worlds with gentle gravitational pull that makes walking feel like floating. A few societies prefer densely grounded realms where gravity is twice, 3 times stronger, where everything feels more anchored, more substantial, more real. These cultures diverge not in conflict, but in perspective. For the first time, gravity is not the silent dictator of evolution and environment. It is part of the palette of human experience, an ingredient, a brushstroke, a tone. Life is more varied than it has ever been. And yet, in all these worlds, one memory remains. Gravity once failed, just for a second, but enough to change everything. The libraries of space-time. Knowledge matures. Science deepens. Philosophy softens into compassion. Humanity begins creating great archives, not of books, or data, or equations alone, but of experiences. In different regimes of gravity, these places are called libraries of space-time. Each library is built in an environment where gravity is tuned to create unique effects. Rooms where gravity is nearly absent, for meditative floating halls. Chambers where it increases gradually, with every step, a slow journey toward weight. Spherical rooms where gravity points inward from all directions, giving the sensation of falling into the center. From every surface, visitors come not to read, but to feel, to understand space-time in their bodies, not just their minds. It becomes clear over time that knowledge is not just mental, it is embodied. It lives in sensation, not only in theory. The flicker taught humanity this, that even the laws of physics can be felt in the bones, in the breath, in the heart. And so people learn physics, not only by studying it, but by living inside it, in different forms. The prophets of the flicker. As with all events that echo through generations, new forms of meaning arise, new forms. Some people become prophets of the flicker, not religious figures, not mystics, but philosophers who explore the existential implications of living in a universe where laws can change. They ask questions like, what is identity in a shifting universe? What is stability, if not guaranteed by nature? What is meaning in a cosmos that can blink? Their teachings are not warnings, they are comforts. They explain that fragility is not failure, that uncertainty is not chaos, that change is the universe's way of remaining alive. They describe the flicker as a cosmic exhale, a release of old tension, a moment where the universe relaxed its hold just long enough for us to glimpse its deeper currents. People listen, not because they fear the next flicker, but because these teachings help them live in harmony with what they cannot control. The prophets remind them, you are not separate from space-time. You are a pattern inside it, a wave in the ocean, a whisper in the corridor, a moment in the cosmic breath, the search for the traveler across the far reaches of the gravitational corridor. A quiet mission persists to find what caused it, or who. For hundreds of years, probes have followed the faint gradient toward regions where space-time is thinner, older, more distorted. Every decade, they discover new anomalies, soft wells in space-time, where gravity behaves like melted glass, large regions with symmetrical patterns that do not match natural causes, ripples that move too slowly and too smoothly to be produced by astrophysical events. Eventually, a theory emerges, once considered too radical to accept. Something passed through, not a wave, not a collapse, not a cosmic defect, a traveler. The signature is too clean, too linear, too deliberate. Not the motion of a star, or a black hole, or a cloud of dark matter. Something controlled, something guided, something advanced enough to sculpt space-time as easily as we sculpt sound. The gravitational corridor, once thought to be a relic, may be a path, a lane, a route carved through the cosmos for beings capable of moving at the scale of gravity itself. If true, the flicker may have been nothing more than the wake of their passage, just as a boat leaves a ripple that rocks the shore for a brief moment. Billions of years after it passes, the universe may have trembled as a traveler drifted by. The question then becomes, will it return? The shorelines of time. Further studies reveal that the gravitational corridor is aging. Its distortions grow softer. Its gradients smooth out. Its edges become diffuse, like footprints eroding on a cosmic beach. This is expected. Space-time heals. Given enough time, it forgets. But the flicker remains forever imprinted in the physics of the solar system, like a birthmark, a scar, a signature. The planets still show minute abnormalities in their orbits, differences so small only the most advanced instruments can trace them. Time itself flows microscopically differently in some regions of the system than it does elsewhere. These imperfections are reminders of the universe's momentary lapse. They are the shorelines of a forgotten tide, the children of the corridor. In deep space, far beyond Earth, a new type of civilization emerges, These are not Earth-adjacent humans. They are descendants of those who chose to live permanently within the gravitational corridor. Over thousands of years, they adapt to environments where space-time behaves with gentle irregularity. Their biology shifts to make use of variable gravity. Their architecture is woven directly into the fabric of space-time, using gravity shaping as a fundamental building tool. Their philosophy is rooted in motion, acceptance, change. To them, gravity is not a rule. It is a tone, a rhythm, a flavor of existence. These beings, whether still human or something beyond, call themselves the children of the corridor, and they believe the flicker was not an accident, not a glitch, not a warning, but an invitation, a sign that the universe is ready to evolve with its inhabitants. They listen to space-time the way ancient humans listened to wind and waves. They hear patterns in gravitational fluctuations. They feel meaning in the tremors. They live in harmony with the long breaths of the cosmos, the return of the quiet. Eventually, the gravitational corridor fades completely. Its memory remains only in historical maps, in ancient data, in the stories of those whose ancestors lived through the flicker. Space-time returns to a deep calm, stable, soft, still, but never again taken for granted. Humanity spread across thousands of worlds and gravity regimes carries a wisdom it did not have before. The universe is not static. It is a process, a motion, a breath. And every now and then, in the long night of cosmic time, it shifts. It changes tone. It trembles. It pauses. Just long enough to remind its inhabitants that existence is a delicate dialogue between matter and the geometry that holds it. And then, as always, it resumes the final calm. When future beings look back on the flicker, they do not see disaster. They do not see chaos. They do not see fear. They see a turning point. The moment the universe, for just 1 second, let its guard down and revealed how exquisitely alive it truly is. They see the beginning of humanity's maturity and our teen and as a cosmic species, not bound to fear, but drawn to understanding. They see the birth of every gravity-shaping technology, every corridor-born civilization, every philosophy that views space-time as a living, breathing realm. They see the start of humanity's true relationship with the cosmos, not as passengers, but as partners. And when the long night ends and the calm light of cosmic dawn returns, one truth remains. Softly, quietly, unchanged. Even if gravity fails again, we will rise with it. We will fall with it. We will learn from it. We will move with it. Because to live in a shifting universe is not a curse. It is a privilege, a reminder that everything that changes is still alive. As we drift to the end of tonight's gentle exploration, let your breath settle into a slow and peaceful rhythm. In the quiet fabric of space-time itself, the memory of that one missing second still lingers soft, distant, and mysterious, like a faint ripple on an endless cosmic sea. Even now, gravity's silent hands hold you, steady and patient, guiding every motion, every heartbeat, every moment of rest. Let that quiet certainty wrap around you. Let it remind you that even when the universe falters, even when reality trembles for a breath, it always finds its way back into balance. Just as you do, feel the calm in knowing that the cosmos is vast enough to change, gentle enough to steady itself again, and old enough to carry you through every shift, every flicker, every pause. And in that stillness, allow your body to soften, as if the weight of the world were cradling you instead of pressing on you. Thank you for joining Science Sleep tonight. May the quiet gravity of the universe hold you safely as you drift into rest. Sleep deeply. Good night.